Okay, 6.4. You're going to need your calculator for this because you're going to want to make sure that you get the same numbers that I have here. If you don't know how already, I'll tell you how to type in the different roots, square root, and then roots that have other numbers in front. So I have the second and the square root button, 58. If there's a negative outside, that just means that the negative is going to come and be part of your answer. But this is the same process, square root of 76. Where you may not know how to use your calculator would be when we have a bigger index in front, like 5. We know how to do cubed roots, math, and that's option 4. But if we use math option 5, we actually are able to put in a different index other than 2 or other than 3. So if your calculator looks like this when you press math option 5, then you don't need to worry about typing the 5 first. You can just type it in exactly like this. If your calculator does not look like that, and it looks instead like this, then you're going to need to put the 5 in before you go through that process. So instead it would look like this. The X won't go away, and then you'll need to enter the information afterwards. We're going to change it back to this because that's what most of your calculators look like. So math option 5, I have the 5th root of negative 43. Oops. Negative 43 needs to go inside. Go through that same process for the 4th root. Make sure that you have the same numbers. You may have noticed up here that when I did the 5th root, it did not give me an imaginary number. When I have an odd root and a negative underneath the radical, my answer will just be negative. That's what this is saying right here. An odd root and my number underneath, my radicand, is a negative number. My answer will be negative. If it was a positive number, then my answer would be positive. And we all know that any root of 0 would just be 0. The problem lies when we have an even root. So example would be like the 4th root. When we are solving an equation, like trying to find the value of a variable, and you have to use a 4th root or a square root or 6th root, any of the even roots, then you must put a plus or minus in front of your answer. If you're not solving an equation, you don't have to worry about putting a plus or minus in front there. So example for that one would be like if I had x to the 4th power equals 16 and I'm trying to find out what x equals, I would take the 4th root of both sides, and because I was solving an equation and needed to use an even root to do so, I have to put plus or minus in front of my answer. Now, if you encounter an even root other than 2, so again, like 4th root, and when you go to work out the problem, whether it's solving an equation or not, if you have an even root of a negative number other than 2, and the number underneath there is negative, you have to say that there's no real roots. If it's a square root, you know how to deal with negative numbers underneath a radical. If it's a square root, you need to put I in front. If it's an even root other than 2, then you just say no real solutions. My pen stopped working here on me. I can't emphasize enough that if you are doing a square root, though, you still need to be able to figure that out. You can do a square root. You cannot do an even root bigger than 2. You can, just not in this course. Turn the page. Let's identify the parts of a radical. This whole thing is called a radical. Now, actually, if you want to get more specific, this symbol right here is a radical sign or a radical symbol. It's not called a square root. That little number that we were dealing with when we took the 5th root and the 4th root and the cubed root is actually called an index. And if that index is not written, you automatically assume that it's 2. That's why when it's written as a square root, you don't have that little 2 hanging out. You've never seen that little 2 hanging out in front because we just don't write it. We use square roots so often that that's the one that we just assume is not there. You see that several times in math. For example, when you see an equation or a variable and there's not a number in front, then you assume that it's 1. You don't always have to write the 1 in front of a variable. Okay, so it's not a new concept to have something that's assumed to be a number. Then underneath this radical is called a radicand. Not a radicant. Radicand with a D. Okay, so I'm going to refer to these parts, so you need to make sure that you are able to look back on them and know what each part is called. When I ask for the index, I'm asking for the little number in front. If I'm asking for or referring to the radicand, that's the part underneath. And when you are asking or dictating what this is, it's not a square root. It's a radical sign. Square root indicates there's not a number. So let's work into simplifying this. Now the process for simplifying this is written out in words up here, but I find that it's easier for us to work it out first, and then you can go back and look at the words. Now, this already had a plus or minus in front of it, so that plus or minus will continue to be part of the answer. I didn't put a plus or minus in front of it because I wasn't solving an equation. So when you see later on and you're trying to find a square root, you don't add a plus or minus in front of it unless you're solving an equation. How do I know that this is a square root symbol? Because there's nothing written in front. When there's nothing written in front, you assume that that index is 2. Now that index is actually very important because it tells you how many need to be in a group in order to come outside of the radical. Now we know automatically that the square root of 100 is just 10. But we don't necessarily know the square root of y to the 8th. So instead we can do this exponent over index. So the exponent is 8 divided by the index, which is 2. Go back to your division roots all the way back in elementary school. How many times does 2 go into 8? 4 times. And there is no remainder. So y to the 4th comes out. And there's nothing left inside of that radical. Okay? To put this in perspective, this is actually the same thing that you've been doing when you made factor trees. It's just a shorter way to do it because we have the same number over and over and over. That y to the 8th is really 8 total y's. And since it's a square root, I'm looking for groups of 2. Four groups come out. Y to the 4th is here. There's no y's left over. Nothing's underneath the radical. So this is a shorthand version so that you don't have to write out all the variables. Okay, let's take a look at the next one. We have a negative in front, so the negative will maintain being in front. We only care about really analyzing what the index is if that negative was found inside. So outside we still maintain. This is a square root because there's not a number written in front, so we assume it's 2. So the square root of 49 is 7. U to the 8th. Exponent is 8. Index is 2. 2 goes into 8 4 times. So that means u to the 4th came out. Exponent of v is 12. Divided by the index, it goes in 6 times. So that means v to the 6th comes out. Next one. We know that this is a square root because there's a 2 assumed to be in front when it's not written. The exponent is 8, so I have 8 divided by 2 is 4. So that means y minus 6 to the 4 comes out. Take a look at D. This time it's the 4th root. You can always try in your calculator first. Can you take the 4th root of 16? And if you did that in your calculator, that's why we practice doing that at the beginning of class. The 4th root of 16 we get is 2. Now we're dealing with exponents and indices. So I have 16 is my exponent. Index is 4. 4 goes into 16 4 times with no remainder. So g to the 4th is here, and there's no remainder. Then we have k to the 24th. 24 divided by 4. 4 goes into 24 6 times with no remainder. So k to the 6th comes out. This is a square root. So we know how to deal with negatives when there's a negative underneath a radical with a square root. That negative will come out as I. We already know the square root of 16, it's 4. We just need to find the square root of y to the 4th. So 4 divided by 2 is 2. So that means y squared comes out. Let's take a look at F. The 6th root of 64. Again, you know how to do that on your calculator with math option 5. You get 2. The exponent is 18. Divided by the index, which is 6. And the answer to that is 3. Now this is important because we had an even exponent, we had an even index, and the answer that we got was odd. That means that there's something extra that we have to do. We have to put absolute value symbols. So we have 2y plus 1 to the third power, and it has to go into absolute value symbols. Okay, here's the reason why, guys. Let's take, for example, 2 to the 6th power, and we'll take the square root of it. Now, I know, guys, that you can type that into your calculator, but I'm trying to prove a point to you here. If we just use the exponent over index part, we would do 6 divided by 2, which is 3. Again, we're in that same position, even, odd, right? So we would have 2 raised to the 3rd power. Now, because we're dealing with a number, it's not a big deal. But what happens if we replace this with an x? We know that the intended answer was for it to be 2 to the 3rd power, which is 8. But if I replace this with an x, and when you solve to find square root symbols, let's say that this was the problem, and you solve it with a square root symbol, you now had to put a plus or minus in front of that square root symbol, right? Which means that that 2 really could have been 2 or negative 2. What happens when you raise a negative to an odd power? It keeps its negative. Okay, so to combat that, we say to put absolute value symbols when you're dealing with an even, and an odd. So that it would always stay that positive number that we were looking for. Okay, let's move on down here and look at G. When you go to type in the cubed root of this, it doesn't come out evenly. So when something doesn't come out evenly when you type it into your calculator, you cannot write the decimal. You need to work this out with a factor tree. 222 divided by, we'll do 2 first. Divided by 2, so 111. 111 divided by 3 is 37. And 37 is prime. So in this case, my factor tree didn't help me. I confirmed that I can't take anything out of the 222. So that needs to remain underneath the radical. But I do know that when I have a negative underneath an odd root, that negative can come out of the radical. So there is still something to do to simplify it. I know how much you guys love fractions, so I just couldn't have a whole thing without a fraction in here. So here's our fraction problem, but it's easier than it appears to be. These are really just 2 roots hanging out underneath the same root. We have square root of x to the 12th, square root of 49. I know that it's a square root because there's not a number written for an index. X to the 12th, 12 divided by 2 is 6. The square root of x to the 12th is really x to the 6th. And we already know the square root of 49, it's 7. I'm going to do 2 more problems. One that's on your paper and one that's not. It's an odd root, so that means I know that the negative that's underneath the radical can come outside of the radical. And I can find the cubed root of 27 in my calculator. It's just 3. So now we're dealing with the 15 and the 18 exponents. So 15 divided by 3 is 5. So z to the 5th comes out. And x to the 18th means that I need to do 18 divided by 3. And that's 6, so x to the 6th comes out. Now, most of these problems were pretty straightforward, but on your homework, you're also going to have some that have some remainders. So let's take a look and see what that looks like when we have a remainder. The process remains the same. Let's do the cubed root of 54, x to the 4th. When I try to do the cubed root of 54, I get a decimal. So that means I need to use a factor tree. So my factor tree of 54, 2 and 27, 3 and 9, 3 and 3. You guys so far in your math career have been used to whenever you do your factor tree, you're looking for pairs. That's because you were doing square roots. The index of a square root is 2. That's why you were looking for pairs. The index here is 3. So we're not looking for pairs, we're looking for groups of 3. There's one group of 3. Take a look at the 4. 4 divided by 3. It goes in one time, and it has 1 remaining. So x to the 1st comes out. Now let's talk about what remains from both the 54 and the x. I took 3 out from the 54, but a 2 is remaining. And I took a group of x's out, but I still have 1 remaining. So on your homework, you're going to have some that you have to do factor trees for, and you're going to have some that when you do division, they're not going to go in nice and pretty. You just need to deal with the remainder the same way we've been doing it.